In our last section, 4.3, we're going to look at inference from samples and experiments. So the process of drawing conclusions about a population based on a sample is called inference, because we infer information about the population from what we know about the sample. That's why our sample has to be a good representation of the population, because we're drawing conclusions about the population. Now, the margin of error compensates for the variability that results from taking a random sample from a population. There's going to be variability in answers. That's okay. Margin of error takes care of that. It does not account for mistakes made during the data collection process. For instance, a biased sampling method will make a lot of mistakes, but the margin of error cannot fix that. It's a mistake in the methodology of creating the sample. Now, what's the benefit of increasing sample size? Well, it decreases your margin of error. That means it helps compensate for the variability in all the different possible answers. It decreases our margin of error. It also increases our precision for our estimate about the population. Not necessarily the accuracy, but the precision. Now, what's the difference? Well, accuracy means you are spot on to whatever the thing is you're estimating. Precision means that all your samples line up in the same place. That's all this does right now, is if I increase my sample size, I'm increasing my precision. It's not dealing with accuracy, it's just dealing with precision at this stage. Now, scope of inference refers to the type of inferences or the conclusions that can be drawn from a study. The types of inferences we can make about the population and about a cause and effect relationship are determined by two factors in the design of the study. The first is, were the individuals randomly assigned to groups? Okay, well, that means an experiment was done where they are randomly assigned to two different groups. Then you'll have to also consider, were individuals randomly selected from a population? That's in the sampling process to get to our experiments. All right, let's see how this works. So let's say, first of all, that our experiments were randomly assigned to groups. Our individuals were randomly assigned to groups. So that means this is all connected to cause and effect relationship. If I can say yes about that, then I can make inferences about cause and effect. So these would be yeses. If they were not randomly assigned to groups, I cannot draw a conclusion that is cause and effect. So these would be no's. Then I have to consider how were the individuals selected from the population? Was it random or was it not random, like biased in some way? Well, if it's random, then I can say yes here, and I can say yes here. If it's not random, I cannot make inferences about the population. I can only make inferences about the certain group it's in, class or age. Now, what does this tell us? Well, this right here would be a perfect world where it was a perfect random sample and a perfect randomly assigned experiment. That's ideal. Well, that doesn't happen very often. Conversely, this is not helpful right here. Don't do an experiment if you don't randomly assign, because it's not helpful. And also, if you sample poorly, you can't draw a conclusion about the population, so the results really don't give us much information. So you have to really be careful about what the design of the experiment and what conclusions you can draw from it. All right, so let's look at this. Is silence golden? Many students insist that they study better when they listen to music. A teacher doubts this claim and suspects that listening to music actually hurts academic performance. Here are 4 possible study designs to address the question at your school. In each case, the response variable will be the student's GPA at the end of the semester. So for each design, suppose that the mean GPA for students who listen to music while studying was significantly lower than the mean GPA for students who did not listen to music while studying. So we're looking at the design of the experiment and trying to draw what conclusions can we make based on this design. Well, number 1, get all the students in your AP class to participate in the study. Ask them whether or not they study with music on, and then divide them into 2 groups based on their answer to this question. Well, it's not a random sample because it's just my AP class, and it's all of them. And did I randomly assign them to groups? No. So my results are only going to apply to that class, which is not real helpful, and I can't establish a cause and effect relationship. Okay, scenario 2. I selected a random sample of students from my school to participate in study. I asked them whether or not they study with music on and divide them into 2 groups based on their answer. Well, it does say I took a random sample of students from the school, so I can draw my conclusions based to the population of the whole school. That would work. But I can't say cause and effect because I divided them based on their answer to the question. So it helps me estimate a population answer, but no causation. No cause and effect can be drawn. Number 3. Get all the students in your AP class to participate in a study. Randomly assign half the students to listen to the music while studying for the entire semester, and have the remaining half abstain from listening to music while studying. Okay, all students in the AP class means it's not random, so it's not going to apply to the whole population, but I did randomly assign the treatments. So I can make a causation conclusion, but I can't draw it to the whole class. So establish causation, but only for that class. And number 4, select a random sample of students from your school to participate in study. Randomly assign half the students to listen to music while studying for the entire semester. Have the remaining half abstain from listening to music while studying. So I've taken a random sample, so I can infer about the whole population, and I've randomly assigned the treatments, so I can draw a causation conclusion. It helps me estimate a population and establish causation. That's the golden ticket right there. That's what we want.